In this video, I'm going to talk about how to describe the shape of our data using 5 magic numbers. Now, let's get back to the example in the lecture, where we collect the data of the daily walking distance for the cat Cheeto. We combine the data sets in March and August together and draw the histogram, which help us to display the center, the shape, as well as the spread of the data. However, the histogram is not always applicable. For example, if your boss asks you to text him the distribution of the data, apparently in this case, the histogram will be no longer doable. Of course, it is also unwise to send him the full dataset, because there will be a huge amount of information. So if that is the case, what should we do then? The idea is that instead of reporting the complete data, we are trying to find some numbers that is the most representative to characterize the distribution of our dataset. So the next question is how to decide these numbers. Remember in the class, one of the measures of the center is the median, which is the midpoint value in a distribution, separating the lower half of the values from the upper half of the values in the ordered dataset. So, described in another way, the median is the value in a dataset at which 50% of the values lies below it. Based on the similar idea, we can find the data point in an ordered dataset such that 25% of the value lies below it, or 75% of the values lies below it. And in a similar way, we can also find the data point with any percentage of the data below it. This type of data is also called percentile, which is the value at which a particular percentage of the distribution lies below. But now, if we just look at the 25%, the 50%, and 75% quantiles, we are actually dividing our dataset into 4 quarters. So these 3 data points are actually also called quartiles. Specifically, 25 percentile is the first quartile, which is usually denoted as Q1. 50% quantile is the second quartile, but it has a well-known name, which is the median. And 75% is the third quartile, which is also denoted as Q3. Now, since you understand the definitions of percentiles and quartiles, in the following part, I'm going to show you how to compute them. We are borrowing a very similar ideas as when we compute the median. First, we need to get our data sorted. If there is an odd number of the values, we will split the data directly into 2 parts by including the median in both halves. Then, for each group, we will find the quartiles in the same way as how we find the median. For example, in our combined dataset, we have 19 data points, in which case it is an odd number. So we will split the data point into 2 halves, and in each half, the median 0.6 will be included. Then, the first quartile is given by the median of the first data group, and the third quartile is given by the second group. If the number of the data point is even, then we can directly split the data into 2 halves and find the median for each subgroup as their quantiles. Once we figure out the 3 quartiles, we can start building our 5-number summary. The 5-number summary contains the 3 quartiles as well as the maximum and the minimum, which can be easily obtained, of course. So in this case, these 5 magic numbers will split our dataset into exactly 4 equal groups. The 5-number summary can provide us a lot of information. For example, we can firstly write out the distance between two numbers. Then, remember the number of the data points in each subgroup are the same. So that means we should expect there are a lot of data sets or data points in a tiny region between the minimum and the Q1. And since the distance of the second region is a little bit wider, which is 0.4 right now, we would expect the density is not that intense like before. And so on and so forth. In this way, we can roughly recover the distribution according to our 5-number summary. Although it is not as fine as the histogram, but it still can provide you a very good intuition about our data distribution. Among the distance that we mentioned just now, there's a very important one, which is inner quartile range, called IQR, which is defined as the difference between Q1 and Q3. This measure provides a very good sense for us about how distribution spreads. For example, if our distribution is more clustered around the center, which is look like this, we would also expect a smaller interquartile range for the new distribution than the original one. So the IQR is basically measure how dense the dataset or data points are between the Q1 and Q3. Thanks for watching. I hope you now understand what is the 5-number summary and what is quartile. If you still have any other question, just log into our course website and post your question on the discussion forum. Okay, I'll see you next week. Bye bye.